Hey you guys, today we're going to be looking at the forecast function in Excel. It's a very simple but very convenient function to have. Basically it does exactly what the name implies that it does. It forecasts or predicts an unknown value based off of data that you've already gathered. So in this example I have the years from 1990 to 2010 as the independent variables, and I have the population for those corresponding years as the dependent variables. Now, I've also set up this chart right here. It's not necessary in order to find an unknown value. I just enjoy it personally, and it's also kind of nice because this function uses the linear regression or the line of best fit for these values, and when you open up a graph you are also able to show the line of best fit, the trend line. And basically how you do that is once you do set up a graph, in this case just a simple line graph, if you go up to the layout, and then the trend line should be up sort of towards the top right. And then if you go down to the more trend line options, just get the linear trend line option, and if you hit the display equation on the chart and display the R² value on the chart, it will pop those up. And the R² basically just shows the closer it is to 1, the more closely the data corresponds with each other. So you do want that closer to 1, and as you can tell this is very close. Now for the forecast, in this example I'm going to try to find, based off of this trend, what the population will be in 2011. Now there's two ways that you can get to the forecast function. Either you can just make sure to click on where you want to insert the function, go into your ribbon under the formulas, more functions, statistical, and then go down to forecast and click on that. Otherwise, if you just hit the equals and you can start typing forecast, hit tab, and that shows up like that. I'm going to use this one first. So if you go to the forecast, it pops this box up. Now the first thing it's going to ask for is the known x, or the x that you are looking for, rather. And in this case, we want to know what the value will be on the x-axis at 2011. So if you just go ahead and click 2011, pops up A23 right there. Now for the known y's, these are the dependent variables. And as I stated earlier, in this example, the population is the known, or the y variable, the dependent variable. So next it will ask for the known x's, which are the independent variables, and those are the years in this example. So go ahead and select those, and then if you hit OK, it comes up with a value right there. And so basically what this is telling you is that based off of this trend, in 2011 the population should be just under 7 billion. Now what I really enjoy about this function is that you can actually flip-flop the variables. So let's say that now instead of knowing what year we're looking for, we want to know, well, in what year will the population reach a certain number? So what I've done is I've said, well, let's see, 10 billion. What year will the population reach 10 billion based off of this pattern? So again, you do the forecast. I'll just do the equals forecast. If you hit tab, that pops up. Now it says the x. Now since we're flip-flopping everything, this is now the x. The population are now the x's. So the x that we are trying to predict for is 10 billion. So I'll just go ahead and click there. I hit a comma. And now we want to know what the known y's are. And like I said, they flip-flopped. So now the known y's are the dependent variables. So 1990, sorry, to 2000. I'll do 2011 since we've already predicted that. Now I'll hit a comma, and now it's looking for the known x's. And we already know what these x's are. So we'll go ahead and select all of those, and we will close that up and hit enter. So based off of these trends, the population will reach 10 billion roughly almost halfway through 2050. Now, I find this really interesting because it is very nice to be able to not have to use this equation and plug in numbers and then do the algebra in your head. You simply hit forecast and you give the data that you already have collected and you ask, where is it? And it populates based off of the linear regression or the line of best fit. Now granted, this becomes less and less accurate as r squared right here gets further and further away from 1. But in this example, it's almost on the dot to 1.
Hopefully
so
this helps, and
fairly
we will
accurate
see in middle of 2050 whether or not this was correct.